So we get a bunch of information about the patient's weight and the dosage and the usual situation, and we have no idea what to do with it until we get to the actual question. And that tells us exactly what we need to do. The actual question here is, by what percent was the prescribed dosage greater than the typical dosage? So first of all, I guess most importantly, this is not asking us, it's a percentage question, but it's not asking us a regular percentage question. It's not asking us one quantity as a percentage of another. It's asking us a percent change question. It's asking us what the percent increase is, or by what percent one thing is greater than another. So we are in percent change territory, and that means our job is to find the difference between two quantities and divide by the original or baseline or reference point of those two quantities. So percent change is defined as difference over original. And if we're going to find the difference between two quantities, it would help if we had the two actual quantities. Often, for most percent change questions, that means we're going to find some old quantity and some new quantity. A lot of percent change questions deal with, well, a change over time. Of course, they don't all. Sometimes they use the same concept, but not dealing with old and new. What's the terminology in this one? Again, let's go back to that last sentence, or the last part of the last sentence, the actual question. By what percent was the prescribed dosage greater than the typical dosage? So here, we're not asking by what percent the new amount was greater than the old amount. We're asking by what percent the prescribed amount was greater than our typical amount. So for this question, it's the typical that is functioning as our old amount or our baseline amount or our reference point amount, and the prescribed is the new or the change amount. But our job is now laid out for us, right? We get the prescribed amount, we get the typical amount, and then we plug in to the definition of percent change. So to the rest of the question. A doctor prescribed 18 cubic centimeters of a certain drug to a patient whose body weight was 120 pounds. So we get one of our quantities right off the bat. The prescribed amount was 18 cubic centimeters. We're also told in that first sentence, this particular patient's weight. We don't know what to do with that yet. In the next sentence, if the typical dosage, all right, this is what we're looking for. If the typical dosage is 2 cubic centimeters per 15 pounds. So typically, we get 2 cubic centimeters per 15 pounds. And I like to think, this is sort of a conversion scenario. I like to think of it just as a ratio. Typically, we get 2 cubic centimeters for 15 pounds, and that's just 2 to 15 is just the ratio of dosage, let's say, of dosage to patient's weight. Typically, dosage to weight is 2 to 15. For this particular patient, and I guess this is cubic centimeters to pounds. For this particular patient, well, this weight patient isn't 15 pounds. This patient is 120 pounds. So let's see, and we're looking for what if we're saying 2 is to 15, as this patient, a typical dosage for this patient is to 120. So we've got an equation. We could cross multiply. We could do all kinds of things. What I like to do is just think about what I would multiply my ratio by, or all the parts of my ratio by, to get the real world counterparts. So let's see, to get from 15 to 120. 15 to 120. I multiply 15 by 4, and I get 60. So if I multiply 15 by 8, I'm going to get 120. So there's my multiplier. 15 times 8 is 120. So we multiply our top by 8. 2 times 8 gives us, means that t equals 16. And I guess what are my units here? It was all in cubic centimeters. But we've got our two quantities. The typical amount is 16. This particular patient got 18, and now we can plug in to our definition of percent change. The difference between the two, 18 minus 16, and what's going to go on the bottom? What's our original or baseline? Well, that's the older typical amount, right? That's the 16. That's the thing that's our reference point for this percent change. So the top, 18 minus 16 is 2. 16 is just 16, and this reduces to an eighth, and ideally we'll just have this memorized and say an eighth is 12.5%, which is answer choice D.